In the previous lesson, I showed how to use traits as pure interfaces, and in this lesson, I want to show traits where we implement concrete behaviors. So anytime you implement the body of a method inside of a trait, we refer to this as a concrete method, and this one, because it does not have a body over here, we refer to that one as an abstract method. So what I do here is what I started to show in the previous lesson. I have implemented behaviors for these two, and then this one has an unimplemented behavior, because as we saw in the previous lesson, dogs and cats have different behavior over here on the right side, so I left those alone. But the tails have the same behavior, so we had this in the has-tail tree. We had this implemented up here. So what I've done here is I just copied that code into my editor over here. So 2 concrete methods, 1 abstract method. And what I'm going to do next is I also want to add one other trait here. So what I'm doing here is I add this new one, and for a very specific reason. So if you look at this line of code over here, what I'm doing is I'm defining this method, and I'm also declaring that this method returns the string type. And the reason I added this other trait here is because I do not show the return type on this one. And I wanted to do this to show both of these are perfectly legal, this one and this one. And I want to discuss the difference between the two real quick. And the biggest thing I want to say is that I kind of, and this is a personal preference, I suppose, but I prefer this approach here. And the weird thing is usually I like my code to be as concise as possible. And when I first started off with Scala, I would write code like this. But then what happens in the long term, I found out, is that when I go back for maintenance work on my code, and it might be a couple months later or 6 months or a year later, when I look at walk over here, and you have to think of this as being more real world code. So the method body over here is going to be much longer than this. And what I find is that when I look at this signature over here, I'm like, well, what in the world is walk? I can tell that it doesn't take any input parameters, but what does it do? It doesn't have any return type here. So immediately I have to come over here and read the method body. If you can imagine that this was much longer, and it had more and more code over here. Something like that. So this is all the method body, and there might be a whole bunch of things here, and then it finally returns a string down here. I'd have to read all this code right here to see what the return type is of this method. So I don't like that personally. I have found out through experience. So again, do whatever you will. But I just want to note that I thought I liked code like this, but in the long term, I actually prefer code like this, because now I just have to read this. And I could say, oh, okay, start tail returns a string. And as long as the method name is reasonably well named, I can probably assume that this is going to have something to do with starting the tail, and it's going to return that information as a string like that. And I didn't even have to read this over here. So anyway, just a quick point. Do whatever you like and then see what works best for you in the long run. But now that I have these traits, I'm also going to add in something different. So what I'm going to do here, and this part is going to be unique to Scala 3. And I'm going to create a trait named pet. And this one is going to take a input parameter, or you can think of it as being a constructor parameter. So a pet's going to have a name. I think pretty much every pet I've ever had has always had a name. And furthermore, so this is the part that's new in Scala 3, is that traits can take parameters. And we say that these are parameterized traits is the technical name for it. But it basically just means that you can have parameters, and if you want to have more than one, you could just keep on listing them just like that. But I'm just going to take in this one right here. And then the other thing you can do is you can use that parameter inside of here. And again, I prefer that to have that string like that, so I will say that. And then I'll say my name is $name. So now, in addition to what I just showed, we're also adding a fourth trait here. And this one takes that parameter name. Then what happens down here is when you finally are ready to start implementing something like a dog class, you will say dog. And now this guy can also have a parameter. And then what you do is you say, well, I want to extend that pet trait, and I'm going to pass in that name. So what goes on here is you're saying this one's going to have this constructor parameter named name, and I want to pass that into pet as I mix in this trait right here. So this is where we start getting into mixing in traits. So I'm mixing in the pet trait and passing in this name parameter as I mix it in. And then we'll add in has tail, has legs, and can speak. So next thing to show is that as you add more and more traits over here, you just include them with commas in between all the names. So you just list them all separated by commas. Then we do the usual colon here to open up our class name. And now, as you can imagine, inside of here, since we are mixing in all these traits, I have to go back here and look for abstract methods. So this is concrete, these others are concrete, but this one is abstract, and that means I need to define that one over here. So I will say def speak, and just to keep that string off of there this time, I will say that. So dog, when it speaks, and again, that's going to return a string right there. It's going to say woof. And the other thing I want to show here is that if you don't like one of these methods, you don't like the way one of these method bodies is implemented over here, these concrete ones, what you do over here is you just say, I want to override that method. So you say override def, I want to override that stop tail one. In here, I'll just say that, oh, the tail is stopped, but I will say reluctantly, like that. So I just wanted to show this as something new. So again, if you want to override a concrete method that's implemented in the trait, you just have to add the override keyword like that. And now we can create a main method to test all this. So I say main def, I'll just call this one main val d equals a new dog. And in the previous lesson, I didn't have any constructor parameters here, but now that I do have one there, I have to give the dog a name. So we'll call this one Rover. And now, so you don't have to watch me type, I'm just going to copy and paste some code in real quick. And there we go. So all I'm doing is I'm calling all of these methods that we have. And I actually skipped the first couple of them, so I want to make sure I do start tail and stop tail. So those are the first ones up there. So I do start tail, stop tail, walk, run, stand still, and then speak. And I want to make sure that stop tail was working as advertised here. And oh, the other one I did was my name, and that one comes from the pet trait. So I save all those. And now up here I named that file traits with default behavior. So we will say copy that, run it with Scala CLI, paste that in. And there we go. Everything works as advertised. And as a quick little summary, in a previous lesson I showed that traits can have abstract methods. And this lesson we got into traits that have concrete methods. And then I noted that classes can extend traits that have both abstract methods and concrete methods. And the only thing you have to do for the concrete methods is add the override keyword. One other thing I want to add from a design perspective is that traits are very granular. And what I mean by that is when you look at this trait here, this has only to do with the concept of an animal having a tail. So there are certain things that you can do, and it could be start tail or wag tail, stop the tail, and then you can have like, the tail can point, it can go up, it can go down, that kind of thing. But anything inside this trait body only has to do with the tail. Similarly, this trait has to do with the concept of legs. So all of these behaviors inside of here only have to do with things related to having legs. And the key about this is nothing in here has to do with a tail, and nothing in here has to do with speaking, right? Because the tail is up there in the top, and then speaking is down here. And when you look at real-world Scala code, you see it's exactly like this. It has very, very granular traits, and then you'll find other code, classes, and objects will mix in these granular traits. And just to demonstrate what I mean, this is the Scala doc for the Scala list class. And then you can see right here that it extends this trait and this one and this one. And I should note that this is Scala 2, and Scala 2 starts with the extends keyword and then uses with for all subsequent traits. So they were using the with keyword as a way to kind of emphasize the mix-in nature of traits. And then in Scala 3, they started realizing, well, it's really kind of long forms to keep typing in with. So they replaced all these with words with commas. But that point aside, the list class consists of this trait and this trait and this one and this one and this one and this one and so on and so forth. And if you dig into these traits, you'll find out that they are probably implemented with more traits themselves, and it just keeps breaking down into smaller and smaller traits. Another way to look at this, if you haven't looked at the Scala doc before, that's one way to see it. And then a nice way to see it down here is that you can see the source code. So you click there. This shows the source code for the Scala list class. And then when we scroll down here, where it started with, this is actually the definition of that list class. And you can see that it mixes in these traits right here. And so these are all very specific traits that have to do with certain things. So this trait has to do with linear sequence. This one has to do with operations on a linear sequence. This one has to do with an abstract sequence. So this is thinking of a sequence at a very high level, and this one is thinking of a very specific instance of sequences that are linear in nature, and a linear just means a linked list. And then as you go on here, you'll find, okay, this has to do with operations of linear sequences. This one has to do with being serializable and so forth. So again, very, very granular traits. And then if you look at the vector class, a vector compared to a list, a vector is an index sequence. So it'll have these other traits that are common, like the index sequence operations and the optimized ones and the serializable ones. But then they'll vary here, where the other one had the linear sequence trait. This one mixes in the index sequence. And if you click on that, you'll see that it extends these other traits as well. And if you keep clicking through here, you'll just keep seeing more and more traits as you go along. So that's just the second key point I wanted to make here, is that traits are very granular in nature. So if you're making them granular, that's perfectly okay. That's the way they're supposed to work.